Hello. Now, in this video, we will do class 10th maths NCRT chapter 2 real number. Now, the today's topic is revisiting irrational number. Okay? So, in a class ninth, we have already discussed about real number. That is, real number is a combination of rational and irrational number. Rational number decimal expansion has two types, that is a terminating decimal expansion and non-terminating repeating decimal expansion, and other is irrational number, that is a non-terminating non-repeating number, that is called a irrational number. Now in this and also class ninth, we have draw a irrational number on a number line. Okay, but we can't prove uh, root 2, root 3, root 5, these are irrational. Okay, the root 2, root 3, root 5, root 7, these are irrational, but we can't prove the root 2, root 3, and we didn't prove root 2, root 3, and root 5 are irrational number. Now in this class 10th, now we are proving root 2, root 3, root 5. Approximately we have said that prove that proving that root p, where prime p is prime, okay, are irrational number. Root p and root p is prime. Basically we in this video we have a proving that root p, where p is a prime, is irrational number. Okay, so now uh, first of all, revisiting the irrational number, here we prove. Now before proving root p is a irrational number, now go through the previous video. We have proved that if p is a prime, if p is a prime and it divides a square, a is any positive integer. What we have discussed in previous video of class 10th. So now if p is a prime, if p is a prime and p divides a square, p divides a square, then p divides a also, p divides a also. We have this is a theorem, and we discussed this theorem in a previous video. If p is a prime, it means if 3 is a prime number and it divides a square, it means we have take a square and p divides a square. Okay, so that is a 36. Let 36, that is a 6 square is 36, 36. And then if 3 divides 6 square, then 3 divides 6 also, obviously. Okay, you to take any example, you will take the 4 2, and if 2 divides 16, that is a square of 4, then 2 divides 4 also. Okay, in this video we will use this theorem also and prove root p is a irrational number. Okay, so let us discuss about the take an example, and now we are proving here. The first is prove that prove that root 2 is an irrational number. Prove that root 2 is an irrational number. Root 2 is an irrational number. Okay. So now proof proof that root 2 is an irrational number. So let now root 2 is irrational. Here we use a contradiction method. Okay, so what the contradiction has said, that if let root 2 is not irrational, it is rational, and let after that after proving, we have said that this is a contradiction. Root 2 is not rational, and if a number is not rational, it become irrational. Okay, so here we use contradiction method. So let root 2 is a rational number, is a rational number. Root 2 is a rational number. Root 2 is a rational number. It means every rational number can be written as p by q form. So root 2 is equal to p by q form. So root 2 is written as a p by q form, where p and q are integers and co-prime. P and q are integers and also co-prime. It is also co-prime. So what is the meaning of co-prime? It means co-prime means if there is a 3 upon 6, so you will cut the 3 1 ja 3, 3 by 3 and 2. It means 1 and now the 1 and 2, 1 and 2 never cut it again. So next is 4 upon 10, 4 upon 10. So 4 1 2 2 ja 4 or 2 5 ja 10. So 2 and 5 are prime. Now 2 comes in the itself table and 5 comes in the itself table. It means if any p by q form has given, we have making them simplest form till they are become co-prime. Okay, so here uh, 4 and 10. Okay, so 4 upon 10, when we have a lots of numbers, we have taken a 3 upon 75. 3 upon 75, 3 1 ja 3, and this is 15 3 ja, sorry, 25 3 ja. So now 1 comes in the itself table and 25 comes, it doesn't comes in a one table. Okay, so any p by q number, p by q rational number has given, and we cut p and q uh, till they become simplest form, till they become simplest form. Okay, so uh, p and q are co-prime. Okay, so root 2 is a p by q form and p and q both are co-prime. It means p comes in the itself table and q comes in the itself table. Okay, now here we prove that p and q are not co-prime. If here the first condition is p by q form and it is a co-prime, it is a co-prime. So now if I am I will prove that p and q are not co-prime. It means p comes in the table of 2 also and q also comes in the table of 2. It means it is a contradiction. Root 2 is p by q form and p and q are co-prime. If they are not co-prime, then it is not a rational number. If they are not rational number, they are a irrational number. Okay, so basically we have said that root 2 p by q form and p and q are q co-prime. Okay, if this is a p by q is a q co-prime, it means root 2 is a rational number. But i am when I am proving the steps, and then after that we have said that p and q are not co-prime. If p are and q are not co-prime, it means it is not a rational number. And if it not a rational number, it means it is irrational number. Okay, so okay, now here, so what we can write here, so root this becomes now, so now, so root 2p 2 q is equal to p, root 2 q is equal to p. Okay, so it can be written as a 2p here. So squaring both side squaring both sides. Okay, so what we get, 4 2 ka square, root 2 ka square is 2, 2 q square upon, okay, 2q square is equal to p square. Or now again q square is equal to p square upon 2, p square upon 2. So now by theorem, if uh, 2, that is prime, divides 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 p square, then it divides it divides p also, it divides p also, obviously it divides p also. So okay, so now again come to the point. Here, here 2 divides, here 2 divides p square, then 2 divides p also, 2 divides p also. Okay, okay, now this is equation 1, this is equation 1. Okay, now put now put q square is equal to, now put q is equal to 2r, q is equal to 2r. Okay, so this is, q becomes 4r square is equal to p square upon, so here is, no, this is p square, so p is equal to 2r, so it becomes, p can be written as a multiple of 2 also. P is can be written as, because it 2 divides p square, then uh, p can be written as multiple of 2, multiple of 2. So here is q square is equal to 4r square upon 2, so you will cancel out the 2, which becomes, simplifies that q square is equal to 2r square, 2r square. So q square upon 2, q square upon 2 is equal to r square. Okay, here 2 divides, here 2 divides q square, then 2 divides q also, 2 divides q also. So now 2 divides q also, this is equation 2, this equation 2, from equation 1 and 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 2, p and q are not co-prime, not co-prime, co-prime, since it divides by it divides by 2, it divides by 2. Okay, it gives contradiction, it gives contradiction, that root 2 is rational, root 2 is rational, hence root 2 is an irrational number, an irrational number, irrational number. Okay, it is easy. Okay, so now in the next video we will do, you will go next video we will do exercise 1.5, and now if any confusion you will pause this video and revise it. Okay, any confusion, you will comment in a comment box. Thank you.